this session, we will discuss the use case which we will be using in our upcoming session in all test tables. So here we are taking into consideration banker application. So banker application is nothing, it's just a application that is used by the bank staff. So whenever a customer reaches to the bank branch and asks for, suppose, to inquire about the balance or to make some debit or credit transaction, then the bank staff uses a banker application. Mostly it's a desktop application, or it can be a web application also. And here what we are considering is we are using this customer API here as a dependency. So here the customer API is a dependent API. It can be a vendor API, or maybe it can be a in-house API which is still under development and not available for testing. So this simple use case we will be using in our upcoming session for all the 4 types of test tables. So let's get started with the first type of test table, that is mocks. Mocks are dummy clone of an interface. So interface can be an API, or it can be a database, or it can be a web server also. So mocks are used to tell all expected action were performed. So what do you mean by this? So in this case, mocks are not used to check how our code or function behaves, or our application behaves on different outputs, whether it's success, failure, or exception. This is not the case with the mocks. In case of mocks, we are just concerned with if that particular function calls the mocks or the backend API, right? So here, since we are replacing the backend API with the mocks, we just need to check if our mocks are being called or not. So mocks are generally stateful, so that help us to identify how many times the function are called, right? To check if the function code or a code in the unit at the unit level is working fine or not. So this is the same thing which we discussed. This is mocks are stateful. So these are not used to validate the return values. So here we are not concerned about the what a mock is returning, whether it's success, failure. So generally mocks do not return any value. Those just consume the request we send from our unit test or code, right, to test our interface itself. But sometimes mocks also return values. Why? Because in case inside your code you need to proceed on further line of codes depending on the outcome from the dependent API, right? So in case of these mocks, if mock will return a value, you can just validate it and proceed with the next line of code or next function. So one more thing to note here is, since those are stateful and we don't check whether what type of output it is giving, or we are not even validating that, so these are used to validate what type of call is being made by that particular function, and whether that mock is called or not, and what are the parameters being sent, if there are any parameters sent in that particular function by that function, right? So let's discuss this with the use case. And one more thing to note here is, these are mostly used by the dev teams, right? So QA teams hardly use them. And and one more thing to note here is, you don't have to write it manually everything. So there are many test frameworks available like Mockito, JMock, and WireMock, which can do that for you easily, right? They can build a function or a class for you, which you can call in your unit code to be unit tested, and that will do the rest of the work. So now we will be discussing this same use case, that is the banker application. So the banker application's transaction now will not go over the web to the real customer API, which our application is dependent on, but it will go to the mock itself. So mock can be a class or it can be a function. And the most important thing is, mocks are mostly built in process. That is, those are within the code itself, whether it's a class right? Or whether it's a function within our code. So here we have taken into consideration we have a get balance method within our banker application. So it uses the HTTP URL connection instance to connect to the API. But here we will connect using the mock, right? So we will simply connect to url.mock. Say you will use the mock here. And next thing is we won't be checking the behavior of our code here or the return values. We will just validate if our code functionality is working fine or not. If it is able to make call to the particular mock which we have defined in this method, that is get balance, right? So here if you can see in get balance we are sending the customer ID to get the customer balance of the balance of that particular customer, the account that customer holds, right? So we can, using this mock we can easily validate whether these parameters are being passed or not, right? Because that will maintain the state itself, so you can easily validate it. So this marks the end of the mock session. So next we will be discussing second type of test table, that are stubs. Stubs is an object that holds predefined data to answer calls during the test. So if you remember, in case of mocks, there is no such data within the mock. Those are just to check the state, like whether that particular mock is being called or not. And the next thing is those are stubs are used to avoid the side effects while using the real data. So side effects here means, so the real data is that is maintained suppose within the database or whether you are querying the API. So those are not according to your test, right? Or either you need to prepare the test data for different type of unit tests, but that will be quite time consuming. So using the stub, you just need to pass your test, or you just need to check how your function behaves using the hard coded data, which you can easily do using different type of tools or using the function or class within the code itself to return the hard coded values. So using this you can check the code functionality. So this is the major use of stubs where it is helpful, where you need to check the how your code will behave with different type of outputs, right? Whether it's a success, whether it's a failure, what kind of response is being sent, what type of data is being sent by the database, right? So using the stub you can even mock the database itself. You can return few records using the collection, like using the maps within the class, right? Or within the function you can return, you will call the stub in your function which is being unit tested, and the stub which is being called will just return back the data similar like the database. And if we say about the API, it will return back a SOAP response, whether it's in a string or a JSON object, right? Depends on what type of API you are calling. So next let's discuss this with the scenario. So here we are using the same use case, the banker application, where the get balance is being called to, and that connects to the stub now in case of the instead of the real customer API, right? And stub will return back different type of response which you can mimic in the stub itself. So one very important thing to note here is you need to advance your stubs according to the application advancement, right? So suppose there are few functionalities being added, you need to create more stubs for that, right? And the stubs are very tightly coupled to the test also. So you can it's not like you can share it with other development teams. It won't be helpful because there are interoperability problems, right? Because those might not be compatible with their applications, or the tests they are doing are totally different from the test the other team is doing, right? So these are few points related to the use case. So this get balance function will call the stub instead of the real customer API. So it will send back the hard-coded JSON response. So let's discuss these remaining points with. So here now this stub will send back the this JSON response, which is sending back the JSON object to the get balance, right? So it is returning back the name balance. So this is the actual response which is as per the API design, right? So we are simply hard coding this in the stub. So it will decide, the stub will decide according to the customer ID or any other value which are passing through the get balance to the stub, right? So you can simply pass your test, or you can check how this behaves, whether if I am receiving a success response. Similarly, if you can also test how the code behaves when you are sending back the error response, like this, the 404 response where the customer is not found. So customer is not there in the database. The customer has no account, right? So this is quite helpful in validating different types of scenarios, and also to check how your actual code will perform in different type of outputs being received from the API, right? So it will just mimic the API responses. So we've already discussed these are very tightly coupled to the test, because different teams have their own application, or they might be testing a different type of the different functions, different code functionalities. So due to this, this can't be shared with the among the different teams, right? So those are confined to the application or to the team itself. So next we will be discussing the next type of testable. Those are fakes. So fakes are almost the working implementation of the system. The working implementation of the dependent component. So these are very close to the production ones, the actual dependency, but are not used in the production. So those are close to the production implementation, right? And so why do we need fakes, right? Are there any flaws with the stubs or the mocks? Yes, so the stubs are just the hard coded data which is being returned, right? Which our function will receive to check different type of output, and how the unit test is behaving with the different type of hard coded data or the output from the stubs. But in case of fakes, you will be dealing with the actual complex scenarios, and those will be very close to the production. Now, right? So how those can be implemented and where we need to do that? Let's discuss that with the use case. So this is the same use case, the banker application one. So here those can be done with the two type of implementation, whether it's a fake class or fake API. So we will be discussing fake class first, right? So here the fake class will return back the real like response. Now let's say consider a complex scenario here. So in our previous mocks or stubs scenario, we were just using get balance to get the balance of that particular customer, but the data being returned was hard coded, right? What if there were few credit or debit transaction performed in a customer's account? Will that stub be able to perform that? No, it won't be able to perform that. So in that case, our unit test will fail. Why? Because the balance being returned will be incorrect. So in that case, these fakes help in the system and testing also, right? Because you can test end to end the complex scenarios also, which whenever the customer API or the real dependent API is not available, right, or still under development. So the fake class here will have its own methods, right, to interpret the different transactions and perform operations, like to reduce the balance or increase the balance according to the credit or debit transaction being performed, and accordingly the get balance will then receive the actual balance like the real, like it is interacting with the real API, right? So that's how these are helpful. So fake class here is the shortcut implementation of the actual code, right? The actual logic. So next we will discuss what are fake APIs, right? So fake APIs, there are many fake APIs available, and you can also over the internet, and you can also create your own fake API. There are many web applications available. There are many GUI tools available using which the testers can easily uh, use them to create a fake API, right? So you can use different type of API assets like WSDL or Swagger files to create the RESTful or SOAP APIs, and those will respond almost like the production ones. So I will show you the example. There are many APIs, inbuilt APIs also available. The ready APIs, ready-made APIs that you can use to test your application, right? If that if if that is compatible with the application, right? So this can also be used to do the performance testing or the integration testing, right? So you can performance test your code itself, how that your application behaves without depending on the customer API if it's not available, or whether it's a vendor API, because vendor APIs have so many constraints. They charge according to the transactions per second, and sometimes the vendor APIs are not available, right? If those are being used in production, then they don't support performance testing. So here fake APIs can be used, right? So let me show you few of the fake APIs and websites which can help you to create the fake APIs. So when you search on the Google regarding the fake API, you can see many options are available, right? So this is one of the fake API request response which I have used multiple times to do a rest assured testing, and also to test my application using this request. So this is an inbuilt API. There are no constraint. This is free of cost. You can use. So these, if you can see, these are the hard coded response, right? And also it maintains the state also. If you are doing any transaction, right? If you are creating a user, it will maintain the state and return back the state, right? Might be for few minutes or few hours until there is a session maintained. Similarly, you have your this one of the side where you can create your own fake API, right? Suppose the get balance where you just need to copy the response body here which you mock, and you can create the API. It will provide you the endpoint which you can integrate with your web application or unit test to test the behavior of your code when the expected output is being sent, right? Similarly, there are many other applications available, websites available which provide this service free of cost.